Hello, my dear students. I am here, Mr. Abdul Nasser Gaber. I am pleasure to meet you today. We will going to study new lesson in trig. It's trig identities. You know, my dear students, that we have studied before the equations. So the equation, if we have this pen and this pen also, they are equal. The left side equal the right side. So it's the equation. But now we will go to study a new lesson which is trig identities. We will study trig identities. Okay. What's the difference between equation and identity? We have said before that cosine theta here equals sine theta in specific cases. We know that if theta equals 45 degrees, okay, then cosine theta will be the same as sine theta equals root 2 over 2, and this one equal root 2 over 2 also. So it's equation because cosine theta equals sine theta only when theta equals 45 or when there's 2 theta equals 90 degrees. And also we can say that sine 30 equal cosine 60. Yes, sine 30 equals half and cosine 60 equal half. So they are equal. But in specific identities or specific numbers. So if we have sine 30 equal cosine 60, it's equation because sine 20 doesn't equal cosine 20 as example. Okay, so it is equation because sometimes equal and sometimes not. They are equal in specific numbers of theta. Okay, so it is equation because sometimes equal in specific numbers or not. Okay, but we will study now new something more than equation, which is identity. We have here, if we have sine theta, if it is negative, then we know that it's equal negative sine theta. And also, if we have cosine negative theta equal cosine theta, because it's even and the negative vanish here. So we know that cosine negative theta equal cosine theta for all values of theta. That means that cosine negative 30 will be equal cosine 30. Cosine negative 20 equals cosine 20. 10 cosine negative 100 equals cosine 100. So cosine negative theta equals cosine theta all the time with all values of theta, whatever theta will be. So now you can say that cosine negative theta equal cosine theta. It's not just an equation, but it is identity. It's now trig identity. So trig identity, it's more than an equation, because equation, the equality limited by some values. But here identity, the equality here for all and all numbers. Okay, let's move, my dear students, to some examples about equations and identities. We know that if we have a graph here, and we would like to draw sine will be like this, and if we would like to draw cosine, okay, we have here some intersecting points, as this point and this point, and so on. These points means that sine theta equals cosine theta at these values, only at these values. Okay, so it is an equation and not identity. Okay, let's move to some examples here. You have to differentiate between them. It's important for you to differentiate between it. Is it just equation or it is identity? We have an example here. The question is, which of the following is identity or equations? Is it equation or identity? Okay, let's say the first example is sine theta equals half. What is it? Is it equation or identity? Let's study it. Sine what number equal half? We know that sine 30 equals half. And what else also? If we have the unit circle as we studied before, we know that we have here 30 degrees, okay, and this is the point, and we have 150. They will give the same as half. Okay, so 30 equal half, and sine 180 minus 30 also equals sine 30 equals half, and not for all theta. Sine 10 as example doesn't equal half, so it's with specific numbers of theta. So this is an equation. Sine theta equals half is an equation and not identity. Let's move to another example here. If we have sine 90 minus theta, sine 90 minus theta, or sometimes we write it as this figure, this shape, sine pi over 2 minus theta. We know, my dear students, that sine 90 minus theta or sine pi over 2 minus theta also equal cosine theta. This function will change by using pi over 2, or will change also by using 3 pi over 2. So sine 3 pi over 2 minus theta also equal cosine theta. But let us discuss about the sine. Here sine pi over 2 minus theta equal cosine theta because it is in the first quadrant. So sine here is positive and it changes to cosine, so it's positive cosine theta. All by using all values of theta, cosine theta here equals sine pi over 2 minus theta, so it's identity. Okay, also this one, sine 3 pi over 2 minus theta equals cosine theta, but what its quadrant? it lie in 270 minus minus number less than 90, so it is here in the third quadrant, and we know that the sign in the third quadrant is negative, so it's equal negative cosine theta for all numbers of theta or values of theta. So it's also an identity. Okay, we have also sine theta. We have here sine theta equal cosine 2 theta. Is it an equation or an identity? I know it's just an equation because it has a specific answer as sine 30 equal cosine 60. This number is double 30. So it's an equation because they doesn't equal all the time. Here also, if we have tan 3 pi over 2 minus theta, of course it's equal cotan theta. Okay, and it lies in the third quadrant, so its tan here is positive. Okay, so it's an identity because they are equal for all values of theta. Okay, let's move to some basic identities that we have studied in first term. My dear students, basic identities are very important for you for keeping them in mind. Why? Because when you have these rules, you will act easily with any identity to prove. Okay? Let me remind you with the basic trig identities. Now, we know that the reciprocal of cosine theta equals the reciprocal of cosine theta is 1 over cosine theta, which is sec theta. So the reciprocal of cosine theta equal sec theta. The reciprocal of sine theta is 1 over sine theta, which is cosec theta. The reciprocal of tan theta is 1 over tan theta, so it is equal cotan theta, and so on. We know also that sine pi over 2 minus theta equals cosine theta. We know also that cosine pi over 2 minus theta equals sine theta, and tan pi over 2 minus theta equal cotan theta. Okay, we have another trig identities, as if we have sec pi over 2 minus theta equal also cosec theta. If we have cosec pi over 2 minus theta, it will be also equal sec theta. If we have cotan pi over 2 minus theta, it equals tan theta. Okay, and if we have just pi means 180 degrees, sine pi minus theta, think carefully about pi and 2 pi or 180 and 360 doesn't change the function, but take care about or pay attention about the negative or positive sign. So sine pi over theta, this will be in the second quadrant, and we know that sine is positive here, and cosine is positive here, and tan is positive diagonally here. So sine pi over theta in the second quadrant, so it's also equal sine theta. Cosine pi over theta, cosine pi minus theta here equals cosine theta, but negative. Why it's negative? Because in the second quadrant cosine is negative. Tan pi minus theta equals negative tan theta, just because it lies also in the second quadrant, and tan here is negative also. Okay, let's move to some other identities that we studied here. We know that sine negative theta, as we said before, equals cosine equals sine theta, negative sine theta. If we have here sine negative an angle, it will be negative sine the angle. And tan negative theta equals negative tan theta, but cosine only, that which have negative here, it will be positive. Okay, and of course it's reciprocal. It's reciprocal of cosine, which is sec negative theta will be equal just sec theta, and the reciprocal of tan, cotan negative theta equals negative cotan theta, and the reciprocal for sine, which is cosec negative theta, will be negative cosec theta. Okay, let's study new identities here for 360. If we have sine 2 pi minus theta, we can write it at sine 360 minus theta. We know this angle will lie in the fourth quadrant here, and sine here is negative, so we can write it as negative sine theta. Cosine 2 pi minus theta, cosine 2 pi minus theta, here cosine is positive, so it's just cosine theta. Tan 2 pi minus theta will be equal negative tan theta. Why? Because tan here in the fourth quadrant is negative also as sine. And of course they reciprocal, you can did the same thing. Okay, let's imitate about some other identities here. We know from the first term that if we have the unit circle here like that, this is x-axis and y-axis, and the length of this radius here equals 1, because it's of course unit circle, and this is the origin point. We know that if we study this point as example, and if the theta here equals 30, so here this part is x and this part is y, and this is right angle triangle, and we know that the diagonal here equals 1, and if we say that a here will be x and y, have the coordinates x and y, so we can say that y power 2 plus x power 2, or x power 2 plus y power 2 here, x power 2 plus y power 2, of course equals 1 from Pythagoras theorem. Okay, what is x power 2? X power 2 here is cosine power 2 theta. Y equals sine power 2 theta. They are equal 1. We can write it like that, sine power 2 theta plus cosine power 2 theta equals 1. It doesn't matter to exchange these two numbers. It's the same because we have plus here. And this identity is very important for us to solve some trig identities. If we divide this identity by sine power 2 theta here, and divide this part by sine power 2 theta, and divide this part also, 1 also, by sine power 2 theta, 1 over sine power 2 theta equal the reciprocal of sine power 2, which is cosec power 2 theta. And sine power 2 theta divided by sine power 2 theta equals 1, of course. And cosine power 2 theta over sine power 2 theta, you know it will be cotan power 2 theta. So it's now very important identity. It's a rule for us to solve some identities. It's 1 plus cotan power 2 theta equal cosec power 2 theta. Remember carefully and pay attention to this rule. Also, if we divide all parts of this identity by cosine power 2 theta, if we divide it by cosine power 2 theta here, cosine power 2 theta, cosine power 2 theta, the answer will be 1 over cosine power 2 theta, of course, will be sec power 2 theta. And cosine power 2 theta divided cosine power 2 theta equals 1. It's a common mistake that some students say 0. Fault. Cosine power 2 theta divided by cosine power 2 theta equals 1. And sine power 2 theta over cosine power 2 theta equals tan power 2 theta. So we have the second important identity here, which is tan power 2 theta plus 1 equals sec power 2 theta, and keep them well. Okay, my dear students, you don't must to keep rules, but you can prove them. If you proved some rule, you cannot forget them. So it's very important to prove. Let us imitate here with some identities. We have here, as we said, sine power 2 theta plus cosine power 2 theta equals 1. From this identity, we can deduce that 1 minus cosine power 2 theta, of course, 1 minus cosine power 2 theta equals sine power 2 theta. And if we say that you want cosine power 2 theta alone here, we can write cosine power 2 theta equals 1 minus sine power 2 theta. And from second one, 1 plus tan power 2 theta equals sec power 2 theta. We can deduce that we can write sec power 2 theta minus tan power 2 theta. Sec power 2 theta minus tan power 2 theta equals 1. Okay, and we can also say that tan power 2 theta, as it is here, and we get sec power 2 theta in this side by negative. Okay, then we will move this one will be equal negative 1. So keep them all. Sec power 2 theta minus tan power 2 theta equals 1, and tan power 2 theta minus sec power 2 theta equals negative 1. Also, we can deduce some shapes of this identity also. 1 plus cotan power 2 theta equals cosec power 2 theta. We can deduce that cosec power 2 theta minus cotan power 2 theta equals 1. And of course, cotan power 2 theta minus cosec power 2 theta equals negative 1. Okay? It's very important, my dear students, for you to keep all this in mind, because if you have them in mind, you can act with the proof which we'll study here. We have some examples here. First example for you, it says that complete. Number 1, we have here sine power 2 theta plus something equal something multiplied by 6 theta equals something here minus tan power 2 theta equals cosec power 2 theta minus something, all of them equals 1. To deal with this complete or this question, separate them. Just say sine power 2 theta plus what equal 1. Yes, we know that sine power 2 theta plus cosine power 2 theta equals 1. Excellent. And this space multiply 6 theta equals 1. Where is 1? This is 1. All these identities here equal, all of them equals 1. So what multiplied by 6 theta equals 1? Of course, the reciprocal of sec theta. The reciprocal of sec theta is cosine. Cosine theta multiplied 6 theta equals 1. Why? Because cosine theta multiplied by 6 theta is the reciprocal of cosine, so it's 1 over cosine theta, so they are equal 1. Okay, let's move to this one. Something here minus tan power 2 theta equals 1. We know that here, if we write 6 theta power 2, yes, it's sec power 2 theta minus tan power 2 theta equals 1. And also cosec power 2 theta minus cotan power 2 theta equals also 1. Okay. We would like to simplify. We would like to answer some questions here. The first part here, to remember some trig identities and to discuss them and prove them. But now we are going to study new examples to prove some identities. Okay, let's move to the first example here. It says simplify. Trig quantities. We have number 1, 1 over cosine power 2 theta minus sine power 2 theta over cosine power 2 theta. Okay, to simplify, to simplify this one, 1 over cosine power 2 theta, of course, will be sec power 2 theta minus sine power 2 theta over cosine power 2 theta. It's of course equal tan power 2 theta, and we know that sec power 2 theta minus tan power 2 theta equals 1. Okay, my dear students, let's go to some break and return again to you. Don't go away. Hello again, my dear students. Let's complete our questions here. We have simplifying here. This question, simplify sine pi over 2 minus theta multiplied by cosec theta. We know that sine pi over 2 minus theta equals cosine theta multiplied by cosec theta, which is the reciprocal of sine theta. Cosec here is 1 over sine theta. So this is over 1. So cosine theta multiply 1 equal cosine theta, and 1 minus times sine theta equals sine theta. So it is cotan theta. Okay. The second simplify sine theta plus cosine theta all power 2 minus 2 sine theta cosine theta. To simplify this expression, we have to expand this binomial power 2. This is sine power 2 theta and cosine power 2 theta, but also 2 multiply sine multiply cosine. Don't forget 2 sine theta cosine theta, and we have already minus, let's write it by different pen, 2 sine theta cosine theta. Now we can cancel this negative 2 cosine theta sine theta with this one, 2 sine theta cosine theta. This is negative and this is positive, so the sum equals 0 here. And we have also sine power 2 theta plus cosine power 2 theta. We know that sine power 2 theta plus cosine power 2 theta equals 1. So the final answer here, simplest form for it, is cosine is equal 1. Okay, let's move to another example here. We have number 4. Simplify that 1 plus cotan power 2 3 pi over 2, which is 270 degrees, minus theta over 1 plus tan power 2 3 pi over 2 plus theta also. We know, my dear students, that tan cotan power 2 3 pi over 2 minus theta 1 plus tan power 2 theta. It's 1 plus cotan power 2 theta here equals cosec power 2 theta. You can say 3 pi over 2 minus theta. Let's write it carefully. 3 pi over 2 minus theta. We know that 1 plus cotan power 2 theta equal cosec power 2 theta, and 1 plus tan power 2, this angle will be equal sec power 2 theta, 3 pi over 2 minus theta. Okay, we know that cosec 3 pi over 2 minus theta, 3 pi over 2 like pi over 2, 270 like pi over 2, it change the function. So it will be sec power 2 theta, and sec power 2 here will be cosec power 2 theta. Okay, and we know that cosec power 2 theta is the reciprocal of sine, and this part will be in the third quadrant here, and third quadrant here sine is negative, so it will be here negative. But when we take power 2, it will be positive, and sec power 2 it changed to cosec power 2 theta. So sec power 2 over cosec power 2 means sec power 2 here is cosine power 2 theta, and cosec power 2 theta here is sine power 2 theta. So it will be tan power 2 theta in the simplest form. Okay, let's move to another equation to simplify. Simplify 1 over sine power 2 theta minus 1 over tan power 2 theta. We know that 1 over sine, we can write it at cosec power 2 theta. And 1 over tan power 2 theta is the reciprocal of cotan power 2 theta. And from the previous rules, we know that cosec power 2 theta minus cotan power 2 theta equals 1. Okay? Because we have 1 plus cotan power 2 theta equals cosec power 2 theta here. And if we change cotan power 2 theta in the other part, will be negative. So cosec power 2 theta minus cotan power 2 theta equals 1. Okay? Let's go to another example to simplify. Also simplify here. We have sine pi over 2 minus theta sec 2 pi minus theta, and we would like to simplify them. We know that sine pi over 2 minus theta directly equal cosine theta, and sec 2 pi minus theta, 2 pi means 360 degrees here, and sec or cosec or tan, cosine, sine, 360 minus an acute angle doesn't change the function. It's also sec theta. But let us imitate with the negative or positive. Sec is the reciprocal of cosine, and cosine in the fourth quadrant here will be positive, so it's just sec theta. So cosine theta times sec theta is the reciprocal of cosine itself. So we can cancel cosine by cosine, but equals 1, because we have here cosine theta times 1 equal cosine, 1 times cosine equal cosine, so cosine over cosine equals 1. Okay, let's write another example here. If we have 1 minus sine power 2 theta over cosine power 2 minus theta minus 1. Okay, we know that 1 minus sine power 2 theta means cosine power 2 theta, and cosine power 2 theta minus 1 equals sine power 2 theta but negative. From where? We know that sine power 2 theta plus cosine power 2 theta equals 1 from the first rule of Pythagorean rule, and 1 minus sine power 2 theta equal cosine power 2 theta, as we said, and cosine power 2 theta minus 1 will be negative sine power 2 theta. So the final answer will be negative cotan power 2 theta, and then we simplified it well. We are going to prove. We have some identities here, some trig identities we want to prove, left hand side and right hand side, and we try to get the left hand side or right hand side to connect with each other. So prove that, number 1, sine power 2 theta minus cosine power 2 theta equals 2 sine power 2 theta minus 1. We want this part, which is left hand side here, equals the right part. This part is just sine, and cosine must be omitting here. So we write sine power 2 theta as it is, minus, we know that cosine power 2 theta, we can write it at 1 minus sine power 2 theta. Why? Because we want sine only. Okay, this is left hand side. Left hand side, sine power 2 theta minus. We omit cosine power 2 theta and substitute instead of it 1 minus sine power 2 theta. So sine power 2 theta as it is, multiplied by this negative will be negative 1 and plus sine power 2 theta. So sine power 2 theta plus sine power 2 theta of course equal 2 sine power 2 theta here minus 1, and this is the right hand side. The proof is completed. Let's move to another example quickly to have very more examples. Sine power 4 theta minus cosine power 4 theta. We must prove that this part equals 1 minus 2 cosine power 2 theta. Look carefully for this expression, my dear students. You will find that we have difference of two squares. From the previous studying in second prep, we have studied that if we have like this expression in left hand side here, you can factorize it. So factorize sine power 4 theta to sine power 2 theta, and this is sine power 2 theta also, minus and plus cosine and cosine power 2 theta. Yes, we know some of you intelligent students say that sine power 2 theta plus cosine power 2 theta equal 1, and we have only sine power 2 theta here minus cosine power 2 theta. Okay, and we want what? We want only cosine power 2 theta, so we have to or must omit this part which sine. We can substitute sine power 2 theta by 1 minus cosine power 2 theta. Okay, minus cosine power 2 theta as it is. So we have here 1 minus cosine and minus sine. We can say minus 2 cosine power 2 theta. Do not forget, my dear students, that we have here 1 negative 1 cosine power 2 theta and the other negative 1 cosine power 2 theta. By adding, it will be negative 2 cosine power 2 theta, and this is the right hand side itself here, and we succeeded to prove that. Let's quickly to another example to prove that sine power 2 theta over 1 minus cosine theta equals 1 plus cosine theta. Okay, my distance, you know that sine power 2 theta equals 1 minus cosine power 2 theta over 1 minus cosine theta. Why we substitute by this one? Because we notice that here in the denominator we have 1 minus cosine. So if we change or substitute by sine power 2 theta by the expression 1 minus cosine power 2 theta, we can deal it with them. This is the left hand side. And the intelligent students say that here 1 means 1 power 2, and this is cosine power 2. We can factorize them by factorizing of different squares. 1 and 1 minus and plus. This is cosine theta and also cosine theta here. We have here 1 minus cosine theta, so we can cancel this part with this part. So the answer will be 1 plus cosine theta. Yes, we succeed to prove that left hand side here equals the right hand side easily. Okay, let's move quickly to another example. Number 4, we have cosine power 2 theta here over 1 plus sine theta. We would like to prove this part equals 1 minus sine theta. Let's use left hand side. It's easy to prove the right hand side. We have also that left hand side here. Cosine power 2 theta, we can substitute it by 1 minus sine power 2 theta. Why we did that? We notice that 1 plus sine theta here in the denominator. So we can change cosine power 2 theta by 1 minus sine power 2 theta, and we will go to factorize. We will factorize this part. It will be different squares, 1 minus sine power 2 theta, and this part 1 plus sine power 2 theta, and we have in denominator here 1 plus sine theta, and we can cancel 1 plus sine power 2 theta with 1, sorry, we have no power 2, we have just 1 minus sine theta, because this is power 2, so sine power 2 equals sine times sine only. 1 minus sine theta multiply 1 plus sine theta, and we will cancel this part with this part, because 1 plus sine over 1 plus sine equals 1. So the final answer will be 1 minus sine theta. And this is the right hand side. And yes, we succeed to prove that the left hand side equal the right hand side. Let's move quickly to another example here. Prove that sine theta plus cosine theta power 2 plus sine theta minus cosine theta all power 2 equals 2. The left hand side here is very big, my dear students. By the right hand the right hand side is small, is equal to, and we have two brackets here. We must expand them, but carefully, because we have binomial. The expand of this binomial will be three terms, not 2 terms. Some of you say sine power 2 plus cosine power 2 and that's enough. No, it's wrong. So by expanding this, sine power 2 here plus 2 multiply sine multiply cosine plus cosine power 2 theta itself. This is the first part, and let us move to the second part. Sine power 2 theta, and this part will be negative cosine. When we will square it, it will be positive, so it will be plus cosine power 2 theta. And by multiplying this part, 2 multiply sine multiply negative cosine, it will be negative 2 sine theta cosine theta. Okay, remember, my dear students, that it is the left hand side only. Okay, notice that negative 2 sine cosine, and this is a positive 2 sine cosine, we cancel them, equal 0. And we have here sine power 2 theta plus cosine power 2 theta plus this sine power 2 theta plus cosine power 2 theta. Yes, I am hearing you, my dear students and the intelligent ones. We have here sine power 2 theta plus cosine power 2 theta equals 1, and sine power 2 theta here plus cosine power 2 theta equals another 1. So the sum equals 2, and this is the right hand side. And we succeeded to prove that this whole left hand side equals 2. Let's move quickly to another example, my dear students. Yes, we have running here because of you, because we complain about trig identities very much. I know that, but when we solve many questions, we will solve it easily. So let's move to the next identity. We have here tan theta plus cotan theta, and we want to prove that it's equal cosec theta multiplied by sec theta. Okay, we have here left hand side. We know, my dear students, that tan theta equals sine over cosine. Some of you ask me why you don't start with right hand theta here, right hand side. Right hand side here is very simple. So, and we cannot make it easily as tan theta plus cotan theta, but we know that tan theta here equals sine theta over cosine theta, plus cotan theta here may be equals cosine theta over sine theta. And by making a common denominator here, we will have sine times cosine, sine theta times cosine theta. Sine theta times sine theta here equals sine power 2 theta, plus cosine theta times cosine theta equal cosine power 2 theta. And we know that cosine power 2 theta plus sine power 2 theta equals 1 over sine theta cosine theta. We can separate them. We can make it 1 over sine theta multiplied by 1 over cosine theta. So 1 over sine theta, you know that it's cosec theta, multiplied by 1 over cosine, it's reciprocal of sec theta. And this is the right hand side, and we have succeeded to prove it very carefully. And my dear students, it's the end. It's my pleasure to meet you today. Until we meet again next Friday, so goodbye and good luck.